This is an example coming up from your textbook, problem solving with rational numbers in fraction form. So we often have real life situations that we could use decimals and fractions to help us. So here's the example from your textbook, and I'll make it a little bit bigger. I'll make it a lot bigger, actually, so you can see it. There we go. There we go. Wow. There we go. There. Whoa. Perfect. So here's the question. It gives us some numbers from the Olympics when Cindy Clausen won the gold medal a number of years ago in Italy. Her winning time was this. How do you read that? 1 minute, 55 seconds. Yeah. 1 minute, 55.27 seconds. Okay? So she did it in 1 minute and 55.27 seconds. Second place was 1 minute, 56.74 seconds. And then the person from the Netherlands was 16/100th of a second behind Groves. Can we write these as mixed numbers? So what we're going to do here, it's complicated because we've got minutes and seconds. We first decide, let's write this only in seconds. Every minute is 60 seconds. Does it make sense if her time was 1 minute and 55 seconds? Add 60 to that. That's the same as 0.27 seconds. And the other person was 116 full seconds, 0.74. Then how do we change this to a mixed fraction? Remember with our decimal, if we go to the hundredths, how could we write 0.27? Thank you. We could write 0.27 as 27 over 100. So changing those to fractions, we've got Christina's time as 115 and 27 100ths and 116 and 16 100ths. So this can help us figure out how much, oh, sorry, there's a typo here. Just see that now. There, 74 100ths. So we can figure out that she beat her by over a second. Can you see that it's over a second difference between the two? And by comparing them with mixed fractions, you can get a different kind of sense of how the math works and figuring out the differences between them. Okay. Now I'll get you to take out your notes. We can add the date here. That first one was just so much writing that I didn't want you to write it down. It is October the 15th. We're halfway through October. Do you believe that we're halfway through October and we've already got almost all of our snow for October? It's probably done. I hope so. Lowest common multiple. Okay? When we talk about multiples of a number, we'll just pick two numbers between 1 and 10. Justin, pick one. What? A number between 1 and 10. Logan, pick the other one. You picked 5. Logan, what number are you picking? 8. So if we have 5 and 8, the multiples of 5 times 2 is 10, 15, 20, 25, 30, 35, 40, 45, 50. I'm out of room, but they would keep on going, right? Multiples of 8 would be 8, 16, 24, 32, 40, 48, 56, 64, and I'm running out of room. So if we add by 5s, those are your multiples of 5. Add by 8s, those are your multiples of 8. Counting by 5s is a good way to practice your times table for 5s. Counting by 8s is a good way to practice your times table by 8s. Okay? When we're looking for lowest common multiple, we look in both of these and say, is there a number in common? And if you kept on going, there's actually a ton of numbers that will be in common. But if we want to find the lowest one, what's the smallest number that's in both? 40. So we call that the lowest common multiple. Where does the lowest common multiple come up? Well, we've seen it already a lot, but we'll find out some questions first. You can write out the multiples of 4 and multiples of 5, multiples of 2, 6, and 8, 6, 8, and 12, and find the one that is the lowest for all of them. Okay, I'll show you what this will look like. You'll do B and C on your own. So write out 4 and 5. Sometimes what I do is I start working on both of them at the same time until I'm like, hey, I stop when I get to 1. That's in common. Sometimes you can do 5 at a time. Do 5 of this one, 5 of this one. See if there's a number in common. If not, do another 5 and another 5, and so on until you find that lowest common multiple. So I want you to try B and C on your own. I'm going to come around and check how you're doing. All right, so for B, you have 2, 6, and 8. Write out 5 of each one. Now, when you write them out, I did 5 of each one just to start. Do we have anything in common yet? No. When figuring out which ones to continue with, in order for something to be in common, well, this one is only up to 10. So it makes sense that I keep working on this one until I get close or I run out of room. In this case, I ran out of room. Luckily, when I ran out of room, the 24 is in all 3 of them. Can you see in the bigger 2 numbers that 24 is the smallest one that's in both of those? So then I was like, okay, it would have to at least be 24 in order for it to match up. And sure enough, with the 2's, 24 was included. 6, 8, and 12. So part C. Change color here. 6, 8, and 12. Okay, 6 is a good thing we've already done the first 3 of those. 8, do the first 3 of those ones. And 12. Now, at this point, like I was doing first 5 of each one, but as soon as I see this, I was like, hey, wait a minute. I'm done. So sometimes you can take a look at the numbers you've already written. We're looking for the lowest common multiple, the number that all 3 of them have in common. And in this case, we were done already. So we didn't have to do 5 of them for 12. Where do we use our lowest common multiple? Well, that's our rule for adding and subtracting fractions. We need to have the lowest common denominator, and your lowest common denominator is your lowest common multiple. So here's some practice for our fractions. When you're adding 2/5 and 3/7, what you're looking for in order to add them is a common denominator. And that common denominator that goes underneath is going to be a lowest common multiple for 5 and 7. Okay? And as you get better at this, some people can say, I can just see it, it's 35. Right? Other people will still go and write multiples of 5, 5, 10, 15, 20, 25, 30, 35. 7s go 7, 14, 21, 28, 35. So 35 is the one that's in common. Yes? And yet one of the things with two numbers that will always work, it's not always the lowest one, but will always work, is Justin saying, I could just take 5 and multiply it by 7, and 7 and multiply it by 5. Sometimes that won't give you the lowest common multiple, but it will always give you a common multiple, and it will always give you a common denominator. Now, if I multiply the first fraction, the bottom, by 7, in order to keep the fraction the same, I need to multiply the top by 7. So this becomes 14 out of 35. And this one, if I multiplied the bottom by 5, I need to multiply the top by 5. And once you have a common denominator, 14 plus 15, 29 pieces. So our final answer is 29 out of 35. Do we need a common denominator for multiplying? No. Multiplying, just multiply the tops, multiply the bottoms. Do we need a common denominator for dividing? No. Dividing, we flip the second fraction and then multiply. Do we need a common denominator for subtracting? Yes. So let's see if you can find a common denominator. It's true, you could multiply this one by 8 and this one by 6, which is 48, but there's a smaller one in this case. So again, if we think about our times table, that can really help us. So I'll give you a little bit of time to work on those.